Welcome to 2.5, page 3. You're going to see that this is exactly like we just got done doing on page 2. So A, find all zeros of the function. When we were doing that, write the polynomial as a product of linear factors. Then they add C, use your factorization to determine the x-intercepts of the graph. Well, the x-intercepts are going to be the zeros provided those zeros are not imaginary. So they might as well just say use your factorization to determine the real zeros. But we will all perhaps already have found the imaginary zeros by then. So really nothing more for us to do here. So I would love to be able to factor this, but I can't come up with factors of 34 that add up to negative 12. So x equals, whoops, sorry about that. X equals the opposite of b, 12, plus or minus square root of 12 squared, 144, minus 4 times 34, that's 120, and 16, 136. 4 times 1 times 34, 136. You can check it. All on 2a2. That's x equals 12 plus or minus square root of positive 8. So we have real zeros because we didn't get a negative there. I can't reduce 2 and 12 yet, but I could make this 12 plus or minus square root of 4 is 2, leave behind a square root of 2, and I get x equals, reduce top and bottom by 2, not the 12 and the 2, but the whole top. 6 plus 2 apples becomes 1 apple when I divide by 2. So there are our zeros. So this is A. And they are also our real zeros, C. These are our real zeros right here. I don't care how you notate that over there, but this is A and C right here. And now we're supposed to write the polynomial as a product of linear factors. So f of x can be x minus that 0. I'm going to go over the top with the plus. Minus, distribute the minus, and I get minus 6 plus minus minus square root of 2. So x minus 6 minus square root of 2. Distribute the negative underneath, and I get minus 6 minus minus. So minus 6 minus minus plus square root of 2. And that's B. Now, understand, A is not always going to be C. It's just that we had real zeros. Okay? 40. Let's try our new trick for testing to see if we can factor by grouping. Why bother trying if we can't do it? So I want to check, is 2 to negative 5 the same as 18 to negative 45? Well, times 9 times 9, you bet it is. This thing factors by grouping. I'm going to factor out an x squared. I get 2x minus 5, which means I should be able to get 2x minus 5 because of that. How do I get that? I factor out a 9. And now this is kind of the mysterious part for some people. Let's imagine what was behind my fingers here was just a. So I had x squared times a plus 9 times a. I would end up getting, factor out an a, I'd end up getting a times x squared plus 9, right? Factor out the a and leave behind x squared plus 9. Well, I'm going to factor out the a. The a is just messy. I'm going to factor out the 2x minus 5 just like it was a. What did I leave behind? I left behind an x squared plus 9. And now, in imagination land, x squared plus 9 factors. It's supposed to be an equals. So I get 2x minus 5 times x plus 3i times x minus 3i, as I said on the last page. If you're not comfortable with that yet, FOIL and see. X squared, got it? Minus 3xi plus 3xi, cancel. And minus 9i squared, I squared negative 1, minus 9 times negative 1 plus 9. We got it. So there's our linear factorization. So write the polynomials linear factors. There's B right there. That's part B. And A is find all the zeros. Well, here's A. Our zeros would be x equals add 5, divide 2, add and subtract 3i. C asks for, use your factorization to determine the x-intercepts of the graph. The x-intercepts, there's only one, and it happens at 5/2. These others are imaginary. Okay? Hopefully that gives you a gist of this, and probably not a bad idea to try 42 ahead of me. However, if you did try 42, you're going to see we're going to run into trouble. And that is what we're going to be talking about specifically for this problem. Take a look here. 1 is, so factor by grouping, 1 is to 10. Is that equal to 33 is to 34? Not even close. Times 33, definitely not times 33. This will not factor by grouping. Doesn't mean that we can't factor it, but it won't do it with our traditional algebra. So this is where I'm going to free you up to your calculator, and I don't have that one in there right now, so I'm going to have to edit that. So we're going to go ahead and graph this. Then I'll explain what we would have to do without our graphing calculator. And if ever there was a section where you had to hug your calculator section, this would be one of the top ones. So let's go ahead. X cubed plus 10x squared plus 33x plus 34. And I'm hoping to find a 0 that I can work with. So let's graph that. Everything look good? Looks good. Oops, you know what? I was zoomed in here. I'm going to pay a price for that, I think. I'm going to have to regraph it. I'm going to go zoom 6. Okay, so we have one real 0, and it appears to be -2. It's probably worth checking that. Second calc value, -2. Okay, -2 is a 0. The other 2 zeros, and we know there's 2 zeros here, or there's 2 more zeros. We got one real one, are imaginary, because we don't cross an x-intercept again. So -2 will synthetically divide this evenly. So I'm going to take -2 into 1. There's no holes here. To the third, to the second, to the first, to the 0th. 1, 10, 33, 34. Because I've looked at my calculator, I know it's going to be 0. Now, prior to graphing calculators, here's what we had to do. We had to take factors of 34 divided by factors of 1 and start synthetically dividing those and hope that we choose -2 pretty soon. But there's a whole bunch you could try before you ever got to -2. You were just kind of blind and had to just start hoping. And there might not even be a rational 0, but we know there is. Times 1, or add it, multiply by -2, 8, times -2, -16, 17 times -2, -34, and we're in business here. So right now this is factored into x plus 2 times x squared plus 8x plus 17. Now, will that factor? No way. We're going to have imaginary zeros. So we got to get those from quadratic formula. So quadratic formula. X equals the opposite of b plus or minus square root b squared, that's 64, minus 4 times 1 times 17, that's 40 and 28, that's 3468. All on 2 times a, all on 2. That is -8 plus or minus square root of -4. That's somewhat nice. That's -8 plus or minus 2i on 2, or reduce top and bottom by 2, -4 plus I. Okay, so, or plus or minus I, excuse me. So here are my zeros. My zeros are part A. So part A, my zeros are x equals -2 is a plain old 0, and then 4 plus or minus I are the others. And then part B, linear factors. For linear factors, I'm going to have x minus the negative 2, x plus 2, times x minus 4 plus I, distribute minus 4 minus I, and x minus 4 minus I, distribute x minus 4, distribute to here, x minus 4 plus I. So that's B, and C wants to know our x-intercepts, which are our real zeros, so that's just x equals negative 2. And that's what we used to do, and that's how we're going to handle number 44. Number 44, I'm hoping there's at least 2 nice zeros to work with, and kind of expecting that. Otherwise, I don't know how to factor with 5 terms here. So let's go to graph. Good time for you to just graph along with me. You're probably quicker at this, young fingers. Let's clear this. X to the 4th minus 8x to the 3rd plus 17x squared minus 8x plus 16. That's a big function, so of course we're going to double check that. X to the 4th minus 8x cubed plus 17x squared minus 8x plus 16. And I think I'm in Zoom Standard, but I'm just going to hit Zoom 6, kind of a habit. And I'm looking for, it would be wonderful if I found 4 real zeros doing this, but I'm hoping that there's at least 2. And I think there are. It looks like 4 is a 0. Second calc value 4 is a 0, but that's kind of a mistake to say that, because truthfully 4 does not appear to be a 0. It's at least a 0. It really appears like it might be 2 zeros, because it looks like a parabola there at 4. So I'm going to go through once with 4 and know for sure it's going to work, but I kind of suspect it's going to work twice. 4, 3, 2, 1, no x's, no holes. 1, negative 8, 17, negative 8, 16. And again, stress what we used to have to do here is we'd have to just start guessing factors of 16 on 1, and hopefully we'd guess 4 pretty quickly. And then we'd have to go through this process until we get 0. But we know we're going to get 0 at least once here, because our graph told us. So 1 times 4, 4, add them negative 4, times 4, negative 16, add them 1, times 4, 4, add them negative 4, times negative 4, negative 16, 0. Okay. Now, what I just learned, and we learned this earlier, I think this is on the previous page, this is now factorable, because 1 is to negative 4 as 1 is to negative 4, but I'm just going to run 4 through it again, because I suspect that 4 is a double 0. Shoot, it might be a quadruple 0 for all I know. So 1 times 4, 4, excuse me, got ahead of myself, add them 0, 0, 1, add them 1, 4, and sure enough, there it is. So I've got x minus 4 squared times x squared plus 0x plus 1. If I set that equal to 0 and factor, I get x minus 4 squared, x plus I, x minus I, and there's my linear factors. That's part B right there is my solution. Part A, my zeros come from right there. 4 is a 0, multiplicity 2, and plus or minus I, those are zeros. And C, notice that's 4 zeros. 4, when it's multiplicity 2, that 4 counts as 2 zeros. That's 2 zeros, 3, 4 zeros. And part C is what as the x-intercept? The x-intercept is x equals 4. It just happens to be a double 0, but it's the only x-intercept on the graph appeared to and is confirmed is 4. So 14-minute video, probably similar time for you to work through those. Ask me questions, let me know how I can help. Thanks a lot.